Now we're going to look at geometric distributions. And what a geometric distribution is it's counting the number of times you have to do something before you hit your first success. And it needs to be binary, which means there's two outcomes, success or fail. And one cannot affect the other. They have to be independent. And we're finding the number of trials before the first success. And the probability of success has to remain the same every time. So they need to give you P, the probability of success, and from P you can figure out Q, the probability of failure. You might need it, sometimes you need it, sometimes you don't, depending on the problem, but you definitely need P, the probability of success. As for formulas, you're mainly going to use the geometric calculator. You're probably not going to need those formulas very often, but mu is 1 over P. It's a good way to calculate it yourself without having to put it in a calculator. And the standard deviation is the square root of 1 minus P over P. So let's look at an example. We have 17% of all pens that were meant to be blue, made by a company, are mislabeled and end up black. So 17% of them are mislabeled, so P equals 0.17. What is the probability that the first mislabeled pen is the 7th pen? So N equals 7, the 7th pen. So we're going to go to the geometric calculator now, and you can find it on the front page of Schoology. You'll see geometric distribution calculator. I'm going to click on that. My P is 0.17. 0.17. And I need the number of trials to at least be the number that they talk about in the problem, which is 7. So 10 is fine. 10 is usually good. There's my mean. On average, it'll take 5.88 pens to get the first mislabeled one. So if they asked for it, the mean is 5.88. All right. So the first mislabeled pen is the 7th pen. So exactly the 7th pen. I'm going to go down to my little table here. So the chances that it's the first pen is 17%. That makes sense, right? Because 17% of them are mislabeled. And here's the chance that it's the second one or the third one. So we want the 7th one. The probability that it's the 7th pen that's mislabeled is 0.0556. So it is, P is 0.0556 or 5.56% chance that the first mislabeled pen is the 7th one. Then they could ask something like this. What is the probability that the first mislabeled pen is the 5th pen or earlier? So it could be the 5th, the 4th, the 3rd, the 1st, the 2nd. And you can find that in Stapllet too. You could take 1 to 5 here and add them up, and that would get you the answer, because if it's any of those, that would be correct. It's like an OR statement. But you also have down here the cumulative distribution function. You'll see cumulative. Cumulative means you keep adding them. So the chance that it's the 5th of the before is from 5 down, add it all up, which is this number right here. This is cumulative, which means they keep adding it up. So 5th or earlier would be 0.6061. So P is 0.6061, like that. Now, another thing they could possibly ask is, on the calculator, they could ask, what's the chance that it is the 6th pen or later that we get our first mislabeled one? And what you would do is you would take 5th or earlier, and if you think about it, 6th or later is the opposite of that, right? Because it's either the 6th or later or it's the 5th or earlier. So it would be 1 minus this 0.6061. So it would be 1 minus 0.6061. So there's a 0.3939%, I mean there's a 39.39% chance it would be the 6th or later. So they could ask it like that as well. And another type they could ask is, what is the probability that the first correctly labeled pen is the 6th pen? Watch, they said correctly labeled. So they mixed the probability up on this one. Correctly labeled would be P is 0.83. Because this is mislabeled, 0.17, so I do 1 minus that, I get 0.83. And what is the chance that is the 6th pin? It ought to be pretty low. If there's an 83% chance, there's no way it should take 6. But let's calculate it just to see. So I'm going to put in 0.83. What is the chance that it's the 6th pin? See, it's almost impossible. 0.0001. So the probability is 0.0001 on that one. And another thing they could possibly ask is, what if they ask, like, what's the probability it's the 5th or the 6th pin? And for a problem like that, we would go up to the geometric distribution here. 5th or 6th is you would just add those two together. 0.0807 plus 0.0670. And whatever they ask, you would just add those together, and that would be the answer if they do an OR statement like that, because an OR statement means you add the probabilities together. All right, that is everything for the geometric distribution problems.